Now that we've discussed and introduced VLANs, let's talk a little bit about the VLAN implementations. Some of the things you need to keep in mind with VLAN, there are ranges on the Catalyst switches. These are the Cisco switches that we use in this course. We have the Catalyst 2960s and the 3560 series switches. They support over 4,000 VLANs. And these VLANs are split into two different categories. We have our normal range VLANs and our extended range VLANs. The normal range VLANs are VLAN numbers from 1 through 1005. Keep in mind that the IDs 1002 through 1005 are reserved for token ring and FDDI VLANs. The IDs 1 through 1002 to 1005 are automatically created and cannot be removed. Also, configuration is stored in the VLAN.dat. It's on the flash of your switches. Also, the VLAN Trunking protocol, VTP, which helps manage VLAN configuration between switches, can only learn and store the normal range VLANs. That's important to keep in mind, that VLAN Trunking protocol, VTP, can only learn and store the normal range VLANs. Remember, normal range is IDs 1 through 1005. Your extended range VLANs are the VLAN numbers 1006 through 4096. You have configurations are stored in the running config, that's in NVRAM, not on the flash, and VTP does not learn extended range VLANs. The VLANs are identified, as I said, with the IDs of 1006 through 4096, in some cases 4094. They support fewer VLAN features than normal range VLANs, and they are by default saved in your running config, not the flash. Again, VTP does not learn extended range VLANs. VTP can only learn normal range VLANs. In order to create a VLAN, we will go into config T on our switch, and then you say VLAN, then you give it the VLAN ID, and you can choose what this ID is. Once you've done this, give your VLAN a name, so that would be name VLAN, and then at this point you can type in end to end this configuration. You can do multiple VLANs at one time. If you need to, you can do that by separating the VLAN numbers by commas. So you can create all the VLANs at one fell swoop and makes your life just a little bit easier as long as you can keep up with it and you have it well documented. You can see what VLANs you have set up by doing the show VLAN brief command, and it displays the contents of the VLAN.dat file. Now here's an example of how we go into switch 1. We've gone into config T. We're going to create VLAN 20. We type in VLAN space 20. We give it the name student, and then we hit end. So now VLAN 20 is set up on this switch, and it has the name student. So let's work through this. It tells us here it wants us to create VLAN 20 and assign the VLAN named student. So we have to go into configure terminal. We're going to create VLAN 20. Its name is going to be student. And then I'm going to type in end. And I can do show VLAN brief. And you see now that I have VLAN 20 set up. Its name is student. It's active. However, there are no ports assigned to this one, and we will get to that here in just a moment, because you do need to associate ports with the VLAN so that you're limiting your traffic flow or you're controlling your traffic flow. Next, we need to assign our ports to our VLAN. So after you've created the VLAN, you've named the VLAN, you now need to assign ports to that VLAN so that there's access to that VLAN. You're going to do this with what's called switch port mode access. And the commands we use is we go back into Config Terminal, we go to our interface ID, we give it a switch port mode access, and then we tell it switch port access VLAN in which VLAN it has access to. So here you see how that is laid out. We've got config T, our interface, F018. That's where PC2 is coming in. That's the PC that we're granting access to. We have switch port mode access, switch port access VLAN 20. So this is a student PC. And then we can end it. Here at this point, it tells us to set F018 to access mode and assign the port to VLAN 20. And then we're going to return directly to the privileged exec mode when we complete this activity. So we have to first go into Configure Terminal, 8, then we're going to do switch port mode access, then switch port access VLAN 20, because that's what the instruction said, was to give it access to VLAN 20. We'll hit end. Then we can do a show VLAN brief. And now you see that the VLAN 20, which is assigned to student, that is its name, is active, and it has port FA018 assigned to it. Now that you know how to assign a port to a VLAN, you also need to know how to change this membership and also how to remove it altogether. You can change the VLAN port membership. You go back into the interface. You tell it no switch port access VLAN, then you type end, and then to verify this, you do the show VLAN brief, and you'll notice that now VLAN 20 student is active, but there are no ports associated with it. I can go back into config T, I can go to interface FA011, I can go into switch port mode access and assign it switch port access VLAN 20. This now puts FA011 onto our VLAN 20. I can verify this by doing the show VLAN brief. You can also delete a single VLAN. You go into your configuration mode again, you do no VLAN and the VLAN you want to get rid of, then type end. You can do show VLAN brief, and you'll notice that we no longer have VLAN 20 student showing. You can verify your LAN information, and you do this by doing show VLAN, and in this particular one its name was student, so show VLAN name student or show VLAN summary. You can also do show VLAN. I can verify my VLAN information. On this one, I'm doing show interface VLAN 20 because our VLANs are considered interfaces. So it says here that VLAN 20 is up, but the line protocol is down. So we can get all the information for our VLANs just like we did for our other interfaces. Now remember that with VLAN we can have VLAN trunking, and the VLAN trunk is an OSI layer 2 link between two switches that carries traffic from all VLANs unless the allowed VLAN list is restricted manually or dynamically. And to enable the trunk links, we have to configure the ports on either end of the physical link with parallel sets of commands. So what we would do is we would go into config T. You're going to go into the interface, so that it knows which interface we're working with. We're going to turn on switch port mode trunk. Then you're going to give it the switch port trunk native VLAN. And remember, by default, your native VLAN is 1, but you should go in and change that. Then we're going to say switch port trunk allowed VLAN, and you're going to give it the VLANs that are allowed on that link, and then you'll do end. We did the switch port mode trunk command because this changes our interface to a permanent trunking mode, and the port enters into what's called a dynamic trunking protocol, or DTP, and it negotiates to convert the link into a trunk link even if the interface connecting to it does not agree with the change. And the dynamic trunking protocol, we'll get into that in just a minute, but you need to keep that in mind, that when we do the switch port mode command, that this interface changes to a permanent trunking mode. Then the switch port mode trunk command is only method to implement the trunk configuration. Just like with the VLANs, once you've set a trunk, if you need that trunk to be removed, you do need to know how to reset the trunk back to its default state. And that one, you're going to go into the interface and you'll tell it no switch port trunk allowed VLAN and no switch port trunk native VLAN. That way it removes this. And you can verify that it has been removed by doing show interface, and whichever interface you've removed it from, switch port. On this one, you'll see that our access mode has been removed for the trunk, and now we're on VLAN 1 by default. And it also says that trunking VLANs is enabled for all ports. Next, we need to return our port to its access mode, and we're going to go back into that interface and we'll tell it switch port mode access, and we do the show interface switch port again, and we'll see now that the administrative mode is static access. We can verify our trunk configuration, and you do that with the show interface, and here we see that our administrative mode is trunk. Our operation mode is trunk. We're administrative trunking encapsulated with DOTQ, and the operational trunking encapsulation is DOT1Q as well. We've got trunking native VLAN on VLAN 99, and our administrative native VLAN tagging is enabled. And you'll see that in the commands where we went into the interface. We set switch port mode trunk, then we did switch port trunk native VLAN 99, and then we ended it. You do need to get in the habit of always verifying that what you've set up for your trunks and for your VLANs, that you did it correctly with your show commands. Ethernet trunk interfaces do support different trunking modes, and an interface can be set to either trunking or non-trunking. It can also be set up to negotiate trunking with the neighbor interface, and this trunk negotiation is managed by the dynamic trunking protocol, which operates on a point-to-point basis only between network devices. Some of the things you need to keep in mind about the dynamic trunking protocol is switch ports can be manually configured to form trunks. Your switch ports can also be configured to negotiate and establish a trunk link with a connected peer. DTP is a protocol to manage the trunk negotiation. It is a Cisco proprietary protocol and is enabled by default on the Cisco 2960s and 3560 switches. With that being said, that other vendors do not use DTP on their switches. If the port on the neighbor switch is configured in a trunk mode that supports DTP, it manages the negotiation. The default DTP configuration on the 2960s and 3560s switches is dynamic auto. So this automatically set to DTP. With the Cisco Catalyst 2960s and 3560s, they support the following trunk modes. We have switch port mode dynamic auto, switch port mode dynamic desirable, switch port mode trunk, and switch port non-negotiate. With the switch port mode auto, this makes the interface able to convert the link to a trunk link. The interface becomes a trunk interface if the neighboring interface is set to trunk or desirable mode. And the default switch port mode for all Ethernet interfaces is dynamic auto. The switch port mode dynamic desirable makes the interface actively attempt to convert the link to a trunk link. And the interface becomes a trunk interface if the neighboring interface is set to trunk, desirable, or auto mode. This is the default switch port mode on older switches, such as the 2950s and the 3550s series switches. Remember, we're talking about Cisco switches. Our switch port mode trunk puts the interface into permanent trunking mode, and it negotiates to convert the neighboring link to a trunk link. And the interface becomes a trunk interface even if the neighboring interface is not a trunk interface, so it doesn't have to shake hands there. Then we have the non-negotiate, and this prevents any interface from generating the DTP frames or the dynamic trunking protocol frames. You can use this command only when the interface switch port mode is access or trunk, and you must manually configure the neighboring interface as a trunk interface to establish a trunk link. So you end up having to configure both ends of it. You should get in the habit of configuring trunk links statically whenever you can. The default DTP mode is dependent on our Cisco iOS software, so it depends on which version you're using. And to determine your current DTP mode, you issue the show DTP interface command to see what mode you are in. Here you see we've done the show DTP interface, and we've told which interface we want to show. You see that it's trunked and it's using the 802.1q. So this shows you which interface it's using. So get in the habit again, not only when you go into switch port mode access and set up your VLANs to show your VLANs to make sure you've done things correctly. Whenever you've set up your DTP or assigned it into which mode you want it to be in, go back in and check it. Make sure that it's doing what you want it to do. Now let's discuss addressing issues with our VLANs. It's very common practice to associate a VLAN with an IP network. And since different IP networks only communicate through a router, all devices within a VLAN must be part of the same IP network in order to communicate. You'll notice in the picture below, PC1 can't communicate to the server because it was the wrong IP address configured. So it's not part of that network. Even if it is in the correct VLAN, it's in the wrong network. To correct this issue, the simplest thing is going to do is to go into your PC and correct its IP address. Make sure that it's on the correct network. Once you've done this, then that PC in VLAN 10 should be able to access the network as long as it's in the correct IP range. If you're still having issues after you've checked for your IP addresses to make sure they're in the correct network, make sure that your VLANs exist on the switches. Make sure things show up like you think they're supposed to show up. So you can do the show VLAN, you can do show MAC address table, and it says, is the port in the correct VLAN? No, assign the port to the correct VLAN. If it is the VLAN present in the VLAN database? If not, create the VLAN in your VLAN database. We can see if it's present with the show VLAN, the show interfaces, and the show interface switch port. So there's multiple ways that we can go about checking to see if we have things set up correctly. If you still don't have good connections or things aren't working the way you think they should, there's still more steps that we can take. We can do the show interface trunk, make sure the trunk lines are set up correctly. So the steps we would take would be to show the VLAN, to see if our VLANs are where we think they are. We can also do the show VLAN and show VLAN interfaces. Next, we would do the show interface trunk command to check to see whether the local and the pure native VLANs match. You know, you can fat finger things into where they wouldn't match, or you may have forgotten to set up one of your VLANs. Do the show interface trunk command to check to see whether a trunk has been established between the switches. Statically configure trunk links whenever possible. And then remember that the Cisco Catalyst switches ports use DTP by default and attempt to negotiate a trunk link. And also to display the status of the trunk, the native VLAN used on the trunk link, and to verify the trunk establishment, you'd use the show interface trunk command. Trunking issues are usually associated with incorrect configuration. You either type something in wrong or you forgot to type something in altogether. When configuring your VLANs and trunks on a switch infrastructure, follow these types of configuration errors. The following are some of the most common. You have native VLAN mismatch. You've either left one at one and you changed the other, or vice versa, or maybe you gave them different numbers. You have trunk mode mismatches, and your allowed VLANs on a trunk. You can have issues there. If a trunk problem is detected, the best practice guidelines recommend to troubleshoot in the order shown above. Check for native VLAN mismatches, check your trunk mode mismatches, and then check for the allowed VLANs on a trunk. With allowed VLANs on a trunk, it causes unexpected traffic or no traffic to be sent over the trunk. An example there would be the list of allowed VLANs does not support the current VLAN trunking requirements. With trunk mode mismatches, it causes a loss of network connectivity. An example there would be that one port is configured as trunk mode off and the other one is on. And then, like I said, with the native VLAN mismatches, you have them with different numbers, so they don't match. Some other things that we can see are that VLANs must be allowed in the trunk before their frames can be transmitted across the link. So if the VLAN's not associated with the trunk, it can't get out. Use the switch port mode trunk allowed VLAN command to specify which VLANs are allowed in a trunk link. And remember to always use your show commands to make sure things are set up the way that you intended them to be set up.